Okay, here we go. We've got a circle theorems question. B, C, D are all points on a circle. And we know that AB here is a tangent. Okay, so as soon as you're told that, you should be thinking of tangent rules. The most common one is the radius one, but we don't seem to have anything to do with the radius going on here. So it's probably not that. And it's probably some kind of angles in the same segment are equal, okay, or no, opposite. The alternate segment theorem, sorry. The alternate segment theorem is probably what they're going to be looking at here. But we haven't got that. We'll probably have to draw it in somewhere. So let's have a look and see what we've got to do and see what we need to find. So we know that AB is parallel to ED. So straight off, we can use that that's 73. And it says you must give a reason. So it's alternate angles. Okay, that's equal to 73. So we give our reason, and then what we work out is we're going to we've got, that's all the information we're given in the question. Okay, so we need to just play with the rest of it, and we want to get the angle of DCE. So we want to get this angle here. This is the one we're looking to try and get. Okay, so we're looking to try and get DCE. We don't seem to know this angle, we don't know that angle, we don't know angle. We're not really getting very far at all at this stage. But if we draw in this straight line here, then what we've got is we have a cyclic quadrilateral. So we know that angle and we know that angle. Well, we don't know this angle, but we do know that angle. We know what these two angles must add up to. They must add up to 180. So we know that DCB equals 180 minus 73, which gives me 103. So that's angles, so opposite angles, so I should write opposite angles in a cyclic quadrilateral add up to 180. Right, you have to give your reasons to get the marks here. So we got that. And then we can see another thing called the alternate segment theorem. We can see that this angle here is just going to be the same as this angle here, which is 73. And let's just keep going. I'm just trying to think. I seem to have made a mistake. I'm just trying to think where I've gone wrong again. 73, well, we know this is 73 because this is 73. And how would I know that? The trick to do is, imagine covering this up with a ruler, okay, and then you're just left with this angle here, which must be the same as this angle here, is a good way to see it. So if we know that's 73, oh, I know I would have made a mistake, I can see it now. You're probably all crying out a minute ago. I took this away and got 103 when I should have got 107. There we go, 107 degrees. Okay, so there's a mistake there. Sorry about that. So now take this. We know that the red one's 103. We know that is 73. Now I want to write that down and write down its reason. So I need to write down ECB, and I need to write down the alternate equals 73 due to the alternate segment theorem. Alternate segment theorem, and therefore everything else is easy. So therefore, what was it? DCE is just equal to 107 minus 73, which gives me 34 degrees. So do remember that the important things to do is to make sure you know all the proper names of your theorems. Okay, Z angles would not do here. You would get 0 for that. Okay, you have to know it's called alternate angles. You need to know that the opposite angles in a cyclic quadrilateral add up to 180, and you need to know what the alternate segment theorem is. Because we've highlighted it, that is enough to explain that.